Today we're going to talk about modeling relationships with functions, and what that means is we're going to look at real life problems and turn those into slope-intercept equations. We're going to plot them on a graph, that kind of thing. The only way to go about this is to just try a few so you can get a feel for it. By the end of this lesson, your lesson objective is this: I can use a function to model a relationship. So you can write a function in slope-intercept form that models a specific real-life relationship. Let's quickly go over some vocabulary. Most of these you've seen before, but we'll do it quick. Linear relationship is a relationship between ordered pairs or between x and y that creates a straight line. With a linear relationship, you always have a constant slope or rate of change. The slope is the steepness of a line. I hope that after the amount of videos that you've seen and the times that we've defined this and talked about it, you'll know how important slope and rate of change is. In order to find the steepness of a line, there are different ways. In an equation, you look for the m, or the number right in front of the x. On a graph, you look for rise over run. And with ordered pairs, you use the equation y2 take away y1 over x2 take away x1. So let's talk about this next vocabulary word: initial value, constant, y-intercept. Those all mean the same thing within a story problem or an equation, okay? If you're reading through a story problem and you're talking about something that's charged to people one time, or something that only happens one time, that's your initial value. And then in your when you put your initial value into a graph or onto a graph or into an equation, that is your y-intercept. So they mean the very same thing. Okay? It's the value in an equation that is not multiplied by something else. Another number. Okay, last but not least, slope-intercept form is y equals mx plus b. The m is slope, the b is y-intercept. So the only good way to do this is to jump right in. Let's look at this first problem. Jerry's Gym is running a special for new members. The fee for joining the gym has been reduced to $25. Members then pay $19.99 per month to use the gym. Write an equation in slope-intercept form to present this situation. Well, I know I have two numbers in here that are important, and I know I'm trying to put it in y equals mx plus b. Now I have to look at those two numbers and decide which one is which, okay? As I read through, I notice that they're going to pay a fee for joining the gym once, and that is $25. That's the constant, or the y-intercept, or the initial value, and so that is going to go in the B spot. And then $19.99 per month means it depends on how many months you have in order to find the exact amount. So that has to go with the X. That changes depending on the number of months. So when we substitute everything into our equation, it's y equals 1999x plus 25. If I put a number of months into this equation, like 1 month or 2 months or 3 months, I will be able to determine how much each person pays for their gym membership. Okay, a plumber charges a fee of $50 to diagnose a problem and then $70 per hour for labor to fix it. Write an equation in slope-intercept form to represent this situation. Well, I know that when he goes to someone's house, he's going to charge them $50 just for driving there. And I read that in the equation. And then $70 per hour every hour he's there working. Since it says per hour, we know that we can substitute a number in for the per hour to find out how much he's charging. So we know that that is the slope. So the $50 is the y-intercept, or sorry, change colors. The y-intercept, or the initial value. And the $70 per hour is the slope. So let's put that into an equation. So y equals 70x plus 50. I could put a number of hours in and figure out how much a person is being charged. What does that look like on a graph? Well, here's the graph. On one side is the total cost in dollars. On the other side is the number of hours. Okay? I start with my initial value because that's my y-intercept, and I plot it right there. And then I know that for every 1 hour he's there, he increases by $70. So 1 would be 120. 2 would be 190. And that's what it looks like on the graph. 1 is 120. That's that point right there. 2 is 190. That's that point right there. And so they go together. They're a linear function, and they, using the slope-intercept form, you can plot what happens per hour that the plumber is at someone's house. All right, here's another. Pierre picks apples at his aunt's orchard on Saturdays during the apple harvest. His aunt pays him a daily wage, plus an additional amount for each bushel of apples he picks. The table shows his earnings. Y if he picks X bushels of apples. So as we read through the equation, we don't get any information. So we have to use what we know. The first thing we want to do is we want to find the slope of this to write an equation in slope-intercept form. Well, we have to remember that we go back to how we find slope in order with ordered pairs, and we start checking the constant rate. So we use our equation. 46 take away 38, 2 take away 1 gives us 8. And let's check our next one. 54 take away 46. 3 take away 2 is 1, so that's 8. 62 take away 54. 4 take away 3, which is 8. 70 take away 62. 5 take away 4, so we're back to 8. So our constant rate, or our slope, is 8. Okay, but how do we find the y-intercept? We don't have a 0 in the x, but can we find a 0 in the x? Yes. When I look at this, the pattern is add 8 to each of these, correct? So if I started at 1, if I want to go back 1 to 0, I just subtract 8. So my y-intercept is 30. Easy peasy, I can put that right into an equation. Y equals 8x plus 30. Probably finding the y-intercept is the hardest, but we have done this before. Okay, so now that we have the equation, how do we graph it? Well, we graph it just like any other equation. So we're going to go back and we're going to put values in. The first thing we're going to do is we're going to plot the 30 because it's the y-intercept and this is the y-axis. So we're going to plot a point on 30. Now we're going to substitute some values in. If we put 1 in for x, we already have the table on the other page. So you could use the table on the other page. That's 38. So now we're going to go over to 1 and up to 30, about 38. And then we know 2 is 46. So we'll go over to 2, up to 46. And so on and so forth. And as we do that, we know we're going to plot a straight line. And we can use that information to draw conclusions from the graph. Okay, very last problem, and this one is a little bit, I think, more complicated because it's such big numbers. A pool is being drained so that it can be repaired. The graph shows the amount of water in the pool during the time it takes to drain it completely. Write the function that is represented by the graph. Well, in order to find the slope and y-intercept, we have to go back to what we know about graphs. Okay? We look for the y-intercept, and when I look over here, I see that it's 6,000. Is it okay to have big numbers like that? Yes. Now, if you remember back, we need to find the slope of a graph. We do rise over run. So we have to find two exact points. I'm going to use these two. One right here, and then I'm going to follow down until I find one that crosses exactly. And it's right there. Now I draw my triangle, sorry. Start at 6,000, 5,000, 4,000, 3,000. Okay, so that's negative 3,000. And then I count over to the right. That's positive. 1, 2, 3, 4. Positive 4. I'm not going to leave it like this. I'm going to divide by 4 because it's not in simplest form. Negative 3,000 divided by 4 is negative 750. So my equation looks like this. Y equals negative 750x plus 6,000. Write down any questions you might have, and we can talk about it tomorrow while you are working on your problems.